Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Hairul Hafizi from Faculty of Electrical Engineering and Technology. Today, I would like to present our project, which is ultra high frequency sensor for partial discharge detection based on Hilbert Fractal model. This is our research team member, led by me, and then the team member, which is Dr. Afifa, our PhD student, Nurdaini, and the others. This is the content of this presentation for today, which is we have include introduction, problem statement, objective, research analysis, application of the model, industrial link, financial, list of application, patent filing, and the copyright details. Okay, in high voltage engineering, the PD, which is the partial discharge, is the electrical discharge of spark that breaks a small portion of the insulation. PD can occur in any location where the location electrical field strength is sufficient to break down the portion of the dielectric material. What is the main reason of the PD happen in the high voltage application? The cause of PD due to aging, environment, mechanical damage, operational stress, and manufacturing defect. The major problem in high voltage power system is degradation and breakdown of the insulation. So the project of Hilbert Fractal UHF sensor has been designed for PD detection on the power transformer. Okay, this is the problem statement that is very we need to concern before we start design and develop for this project. The first is aging of the equipment and the breakdown of the installation. The PD at the power transformer occurs because of the unscheduled maintenance, aging of the equipment, breakdown of installation, gas bubbles in insulation liquid, and the manufacturing area. And the second one is a failure of transformer, because the last portion of the power transformer failure are caused by fault of oil paper insulation, which often start with PD. And the sensor also, this is the other sensor that which is have a limitation issue, because there are some limitation in microstrip single antenna, which is the low gain, narrow bandwidth, with a low efficiency. So according to this problem statement, so we need to develop the new one, the new generation of the patch antenna that suit with the partial discharge detection in power transformer. Okay, the objective for this project, we need to start with the two model, an optimal design based on the sizing of the patch antenna that match with the frequency bandwidth of the PD signal in range 1.2 GHz up to 2.5 GHz. And then we need to fabricate the new generation that have been model. We get the optimal design. We need to fabricate the new generation UHF antenna with the early design with the and the partially ground of the antenna to make sure the antenna suits with the partial discharge detection for the power transformer. And the last one, we need to analyze the performance of the proposed antenna in terms of sensitivity, resonant frequency, approaching the frequency range of the PD signal in the power transformer. Okay, this is the comparison model compare with the other sensor, which is the attributed planar sensor, the conical antenna. That why we need to choose the partially patch antenna, because this is a small, easy to be installed in the power transformer, because the transformer itself in the industry is very limited space, so we need to design, we still need to select the best one of the patch antenna. Okay, actually, what is partial discharge? So the current issue, in order to have reliable energy and power system, knowing the status and the condition of the electric equipment and its insulation is essential. So the study has shown that main cause failure of the power equipment is degradation of the insulation due to constant mechanical, electrical, and thermal stress. So the PD signal is an electrical discharge that partially breach the insulation between the conductors as a result of electrical distress on the surface for the insulation. So the PD factor that we have know, especially in the power transformer, we have a void of the in the oil insulation. Okay, so for the UHF PD detection, the PD detection can be found in high voltage equipment such as switchgear, underground cable, transformer, generator, and others. So the UHF method is an effective technique for PD detection, especially in the switchgear and transformer. So the location and detection PD is important to avoid damage that ensure the safety of the environment. So if we can see based on the reporting, the percentage of the insulation failure, the highest is which is the transformer. So we need to focus on the power transformer to detect the partial discharge before the equipment breakdown. So this is the pre-fault action before the transformer become worse. Okay, so we choose the Hilbert Fractal UHF model, but however, this sensor need to suit with the partial discharge model with in the range of the frequency and the size and the sensitivity of the sensor. Okay, this is the experimental setup have been done in the high voltage laboratory in the USM to analyze the performance of the development of the sensor. Results for the S11. So we have a three analysis, which is single Hilbert fractal, and then the second one array Hilbert fractal, and the last one the partially ground of the array Hilbert fractal sensor. So if we can see here, the result shows the proposed of the Hilbert fractal sensor with the partially ground. The gain is a very good condition. So it's much more higher the gain. So the sensitivity of the sensor will be increased. So same goes to the frequency band. So the frequency band in the range of the partial discharge signal. Okay, this is the radiation pattern of the sensor. So we have for the single Hilbert fractal sensor. So this is the analysis, and then the array Hilbert fractal sensor, and this is the proposed with the partially ground of the Hilbert sensor. So we can see this is the very good pattern of um, uh, the the radiation pattern of the sensor. We select the three frequency, which is 1.31 gigahertz, 1.57 gigahertz, and 2.1 gigahertz. And this is actually this is the experiment setup that have been done as shown before. This is the diagram in the high voltage laboratory. So we use the test cell, okay, to initiate the partial discharge PD source, and then we also compare with we also verify with the IMC sensor. So we need to validate the performance of the UHF sensor, so to make sure the UHF sensor can detect the accurate signal, and then not the noise of signal. Okay, so this is the experimental results to compare to validate between UHF and IMC. So if we can see here, the the red one is the IMC, which is the reference of the sensor, and the green one, which is the UHF sensor. So if you can see, the signal is same with the IMC. So that's mean the UHF sensor can very well detect the PD signal. So this is the three different of the results, which is the single Hilbert fractal, array Hilbert fractal, and the partially grounded Hilbert fractal. So if you can see here, based on the results, the partially ground shows a good result with a high sensitivity. So the advantage and the novelty of this project, the advantage which is the high sensitivity wide bandwidth of sensor, strong anti-interference, very efficient for localization of PD, low cost, easy and safe installation, lightweight. So one more thing, we can monitor the power transformer in the online condition. So we no need to switch off the power transformer. So this is a very good condition to monitor no energy interruption of the power system. So the novelty, which is the new design of 4 Hilbert factor sensor for PD detection, and this is the application for the commercialized and commercial potential, which you can use for the high voltage power transformer, gas insulated switchgear, and then the commercial potential for the transformer manufacturer company, transformer service maintenance company, and for the industrial link we have the TNBR uh, and LAJ kejutan. Okay, this is the letter of intent, okay, from the Southern Cable that we collaborate for research and R&D for high voltage application. And the collaboration before the COVID have been visit to the Southern Cable at the Kuala Ketil on 2019. And for this project also funded by the FRGS that have been approved for new partial digitization based on UHF sensor using segmented correlation trimming data filtering algorithm for power transformer that approved, which is 98,200 ringgit. This is the financial plan that have been proposed for this project as a startup of the company. Okay. Uh, okay, this is the financial plan in for the 1 year, include this product. Okay. Okay, this is the list of publication that have been related to the power transformer for this for this project. And then this is the copyright for this project, ultra high frequency sensor for partial detection in 2023. And this is the patent filing actually for partial discharge monitoring system that have been filed during 2019. Okay, thank you very much.